Oh, I couldn't record from anyplace else. Okay. So you want to look in two problems in chapter 6 and 2 problems in chapter 7.
Correct.
6, 64. Systolic blood pressure given in millimeters. Males, it's approximately normal distribution with a mean of 125 and a sigma of 14. Systolic blood pressure for males follows a normal distribution. Why would they say that? For males, approximately. Has an approximately normal distribution. Systolic blood pressure follows the. That's a really weird statement there. Calculate the z-scores for the male systolic blood pressure of 100 and 150. If a male friend of yours said he thought the systolic blood pressure was 2.5 standard deviations below the mean, but believed his blood pressure was between 150, what would you say to him? Okay. Let's do 63.
Okay.
Which is somewhat similar. I don't even think you need software for this. Okay. So this is similar to, oops, I got it in the wrong one here. Okay, the heights of the basketball players has an approximate normal distribution with a mean of 79 and a standard deviation of 3.89 inches. For each of the following heights, calculate and interpret the z-score and interpret it using complete sentences. So we have mean equals 77 inches. The standard deviation.
Well, the mean is actually 79.
79, yeah, I see it. Equals 3.89. 79. Okay, so this is inches. I don't have to do this, but I'm going to do it anyway. Why? Because I want to. In feet, it is let's see, I think that's 6 feet 7 inches. Well, let's see this. 79 divided by 2, 12, 6.58. So it's 6 times 12 is 72. So yeah, it's 6 feet 9 inches. Wow. Is that right? It seems high. Yeah, 72, 6 foot 7 inches. I can't do mathematics. I can't do arithmetic. It still seems high. But they're big boys. Okay. So A. And I'm like, what's a z-score? I don't remember what a z-score is. So let's go to the standard normal distribution. Well, gee whiz, there's a definition of a z-score. Why don't we use that? I'll copy it and put it right here. That's the formula I would use. So if X, let's put this down one. There's no right way of organizing this. X z-score. I'll left justify it. And what's my first X? 77. What's my next one? 85. So how do we find a z-score? It equals X minus the mean. X minus the mean divided by the standard deviation. But that will be the wrong answer because I have to divide the whole numerator. I have to put parentheses around the top part so it knows to divide both. And how many? 2 decimal places. All I need. I'm doing the wrong thing. Undo, 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 undo. No, redo. And how many decimal places do I need? 3. That's good enough. Okay. Do I have to do it again? I could just calculate the same thing. Equals that. Well, in fact, let's make it simple. Let's put parentheses. That minus 79 divided by the standard deviation. Did you have trouble with that part?
Yes, I did. So, well, let me just get the process down. So you started with the X, so 77 minus the mean divided by the standard deviation. Is that what you did?
That's exactly what the formula says.
Gotcha.
So if you want, you can write this as mean, or the Greek letter mu. Standard deviation is the Greek letter sigma. X is the number you're trying to find the score for.
Gotcha.
What's the interpretation? You wanted to interpret it in full sentences. I don't know, what would I say for this? A player of height of 77, that is 77 inches tall, is approximately half a standard deviation below the mean of 79 inches. So if I want, I can wrap the text. Maybe I'll make the text smaller. And do I want it to look pretty? Sure I do. Maybe I'll make everything in the middle like that. Maybe I'll make this a little bit bigger to make it 2 rows. There we go. There's my answer for that one. A player, and really it doesn't matter now. I just change the numbers. Of 85 inches tall is approximately 1.5 standard deviations, in this case, above the mean. And I could wrap that text And I can make it size 10 font. And I could do what? I could do that. Okay.
Okay.
Do you see, does the problem that you're looking at have the same thing? Homework, you were looking at what? 60 systolic blood pressure. Calculate the z-scores. Yeah, of two things. Then ask you to interpret it. If a friend of yours thought his blood pressure was below, well, this one says if an NBA player reported his height 3.5 standard deviations above the mean. So now we're going to give a z-score and look for what the player's height is. Okay, so which means you have to solve the problem the other way. You have to, for this equation, it's still the same kind of equation, but I'm going to multiply both sides by sigma, z times sigma plus, hold on a second. Hold on. Sorry about that.
No worries.
All right, so if I was, can you solve that equation for x? Z equals x minus mu over sigma. Can you solve that for x? Why don't you do that while I set the problem up? So this problem is going to say C, a D, yes, problem C. And I'm going to give you a z-score. And now we want the height. It's the opposite problem. We want the x.
So the formula you have, it's basically what we've been doing for the past two problems. So how would the formula look in this last one?
That's what I'm asking you. I asked you to solve for x in this equation.
Okay. So. I'm not really sure, but in the equation, I just plugged in the 3.5 into the x.
No, I wanted you to solve that equation for x. I didn't want you to put any numbers in it. I want you to take z equals x minus mu divided by sigma, solve for x. X equals what? We're doing it backwards. They're giving you a z-score and they want to find the x.
Okay.
That's what that last part is about.
Yeah, I'm not really sure where to start.
I'm sorry?
Yeah, I'm
Multiply
not
both
really
sides
sure.
by sigma, and you get z sigma equals x minus mu. Then add mu to both sides, and you get this formula right here. Z
Okay.
times sigma. I'm not using the Greek letters. I'm just writing it out as words. It's easier in Excel that way. Plus
Sigma
the
is
mean
sigma.
equals x.
Okay, so sigma is the standard deviation.
Mhm.
Okay, just making sure. Not really familiar
So
with the
what's
terms.
the z-score?
3.5.
3.5. And yeah, I'm using half Greek letters, half things. I should, if I did that, I should write this, good point. I should write this as mu. Or I can write it as this way. Z times standard dev plus mean. At least that way it's consistent. Equals x. So there's 3.5. So I want to multiply it by the standard deviation. 3.5 times standard deviation plus 79 inches tells me the person is 92 inches tall. 92 inches, if I take 92 and divide it by 12, it's 7 feet 7 inches. Is it likely we have a 7'7" player?
Not very likely.
Not very likely. Would you believe him? He'd
No.
have to be 7.7 inches. So 0.7 is what of 12? Equals 12 times 0.72. Let's say 0.72 is he's 7'8". This would make the player (7 feet 8.5 inches tall, right? Or 8 inches tall. Let's just round it up. Let's say 8 inches tall, which is probably unlikely. Why don't you, while I'm doing, wrapping the text and changing the font size, Google what's the tallest player in the NBA? How tall is the tallest player in the NBA?
The tallest player in the NBA is 7'7".
Oh, well, okay, so but it's unless it's that guy,
Yeah.
person ever in the NBA. Let's see, ever in the NBA. Well, still, do you think it's likely?
No.
Assuming it's an average person.
No, it's not an average person at all.
Okay, the list of the tallest player. It's currently topped by Gorge Morishon, 7'7". Let's see, who was the tallest player? Manute Bol was 7'7". Taco Fall, never heard of that guy. So I think that right now is the tallest player. This would be 7'8". I'm going to say it's very unlikely that this guy is telling the truth.
Okay.
Which is probably unlikely to be true. It's just my interpretation. Now, calculating the height of 92.6 inches and turning that into feet, 7.8 inches, I think that's factual. I mean, that's real. But now the interpretation is really up to you or me to decide that. So let's assume that probably not true. So now you think you can do this?
64? Yeah.
Yeah. A male friend of yours says his blood pressure is 2.5 standard deviation below the mean, but believed his blood pressure was between 100 and 150. What would you say to him? Well, you calculate that based on the mean and standard deviation, just like we did. And if it's between 100 and 150, you tell him, hey, you're right. If it's below 100, you tell him, nope, sorry, you're not right. I guess.
Gotcha.
So what do we do here? We had 60, that was 64, and we had to do 74. What's 74? Using a normal distribution. IQ is normally distributed with a mean of 100, standard deviation 15. Suppose one individual is randomly chosen. Let X equal the IQ of the individual, and then they ask you all these questions about it, right?
Right.
There's D parts to that one. And the ones before and after it don't have a D part.
Okay.
Graph and write the probability statement. Find the probability. Let's see, what do they have? Find the probability IQ lose quarter, sketch a graph, write a probability. Mensa's the top 2%, so that's 98th percentile. And the middle falls between what two values? And that's an in-between probability. So maybe we'll add one for, what do you want to do? The one on fat calories or the height of Asian adult males? I'd rather do fat calories. I don't know why. Nothing against Asian adult males. Okay, so let's do this problem. Okay, how would I organize this? The percent of fat calories that a person consumes each day is normally distributed with a mean of 36 and a standard deviation of 10. So A, pretty easy. How would you answer A?
So it'd be X and the dash with the N for normal distribution. And in the parentheses, you would put 36 and 10.
That's exactly right. So in this case, the mean or mu is equal to 36, and the standard deviation, which is equal to 10. Okay. And the question B is find the probability that the percent of fat a person consumes is more than 40. Graph the situation. That's a right tail, is it not? More than 40.
Yeah.
So I have to do a less than. Well, the easiest way to do this problem is to use the calculator that I gave you.
Okay.
So where's the calculator? I should have it on here, I think. Unless I closed it already. I did close it. Silly man. File, open recent, continuous probability distribution calculator. There it is, normal distribution right there. Okay, so what's the mean? 36. What's the standard deviation? 10. And really, I'm looking for 40. Yes?
Correct.
So my right tail is 3446. So if I was to just say copy, let's take a picture of just this. And maybe I'll make it 40 for both. The lower number and upper number, it doesn't matter. It's giving the same answers. In between is therefore 0. And I do this and I say I have to make it big. Probability that X is greater than 40 equals what? What would you say it was based on this?
0.344 or 3446.
0.3446. There we go. That answers that. C. Find the maximum number of lower 0.25% fat calories. Oh, percent of fat calories. These are percent of fat calories. Okay. I should read the problem. Not that it matters. I know how to answer it without actually reading it to find out what we're doing, but it always helps to know what you're doing. Okay. Now we're looking for what number are we looking for here?
We're looking for a percentage.
We're looking for the other way. We want to find we're using the inverse now, and we want to find the lower quarter, the maximum number of the lower. So what's the 25th percentile? Let me do it this way. Percentile. Well, how do we get that? I mean, there's two ways. I can do it this way. I can do norm dot inverse. So I'm not using the table. I'm not using the calculator this time. But the probability is going to be 0.25. The mean is 36. The standard deviation is 10. Boom. So at that, it's like 29.26 calories. How do I know I'm right? Well, let's put 25th percentile here, 0.25. And it gives us 29.2551, which rounds up to 29.26. Good. Let's do this. D. Middle 50 percentile, which is like in the problem that you asked about. So here we want to calculate a lower limit. And we want to calculate an upper limit, right? So if I go here, well, I already got the lower limit. What if I put 29.2551 in there? That gives me 25% left tail, 75% above. What if I find the 75th percentile, which means that the right tail is 25%. That's 42.7449. Now, I'm not good at graphing on this, but I could probably sketch these graphs on a piece of paper, take a picture and put it in. And that gives me my in between of 50%. So if I copy this X low and X high, that's really what I got here. So if I just copy this, well, might as well copy the whole thing. And I will make that much smaller. I'm using the calculator to make my life easier, right?
Right.
Are you following?
Yes.
Okay, and then you can watch the video countless times if you need to. And I probably should make a YouTube of this. Okay, so the middle percent, the lower limit is 29.551. And the upper limit is 42.7449. Boom. That's how we do a problem like 74. We did 75 instead. So now let's look at chapter 7, number 72. I wonder if we did that the other day. Did we? Oh, that's just true and false. Which of the following is not true about the theoretical distribution of sums?
Oh no, I was talking about 62 and 64 for chapter 7.
Which one?
62 and 64.
62 and 64. Why do I have 72 and 74? Because I can't hear.
It's all good.
Let's say 62 and 64. Okay. That's easy. 62. Okay. Suppose the distance that fly balls in outfield is normally distributed with a mean of 250 and a standard deviation of 50. We randomly sample 50 fly balls. What's the distribution of that, of the sampling distribution of the mean? Okay, what's probably that 49 balls traveled an average of less than 240 feet. Scale a horizontal axis, shade the region corresponding to the probability, find the probability. Well, we're just finding the probability. And what's the 80th percentile? Well, once I get my X bar, it's just like a problem we already did, right?
Right.
So really the problem is finding A. So let's do 63. If you can do 63, you can do 62. All right. So A is asking for the distribution of the individuals. According to the Internal Revenue Service, the average length of time individual to keep records for, learn, prepare, copy, assemble, and send the IRS Form 1040 is 10.53 hours without any attached schedules. So, and the distribution is unknown. Let us assume that the standard deviation is 2 hours. So what is X equal to?
Do we have to do that same process from earlier with the
Let's say X is equal to.
okay, so the
See right here, the average length of time an individual to complete IRS Form 1040. That would be enough for me.
Yep.
They give it to you right in the problem. The average length of time, if I wanted to put it in hours, that an individual takes to complete Form 1040 with no attachments. Very good. So let's make this, I don't know, how do I want to do that? Let me wrap the text. Let me make it much smaller. Let me put everything in the middle. Doesn't it look beautiful? B. What's the district? So for this, well, let's not do B yet. The mean for this is what?
oh, I'm looking for it. Looking for it.
How long does it on average take a person to do it?
10.53 hours.
Mm-hmm. What's the standard deviation? And I'm sorry that this is made this so big. Make it smaller. so it doesn't look so awkward.
Oh, it's two.
Make that smaller. Not that one. That one. There we go. All right, so what's standard deviation?
2 hours.
2. Okay. We don't know what the distribution is. So now we have B. We have a sampling distribution, right? Yeah, put it over here. Okay, and we have n is equal to what?
36.
Yes. 36. And now we have to find the mean. We have to find the x bar. Well, the mean of the sampling distribution and the standard deviation. And maybe I don't remember how to do that, but I go to formulas. In this, ooh, there we go. If we have x bar has this distribution, right?
Correct.
So that's what the formula we use here. If I want to not toggle back and forth, I can just copy that and put it right there. Doesn't like that. Why does it work sometimes and not other times? Come on. There we go. Limit theorem. So the mean is the same mean. The mean doesn't change. No matter what this distribution is, the mean is going to be the same. But the standard deviation is going to be what? Equal to 2 divided by the square root of the sample size. What's the sample size? 36. Close parentheses, so it's 0.3333. Let's reduce that to maybe 2 decimal places. Is that what B wants? Yes. Well, C is a rewriting of that. X is distributed. How is it distributed? Normal of what? 36, 10.53, comma 0.33. Close enough for government work. D is asking the question what?
Can you repeat how you got the standard deviation for B?
It's that formula. Standard deviation divided by the square root of 36.
Gotcha.
Standard deviation divided by the square root of 36. D14 divided by the square root of D18. What's D asking us for? Would you be surprised if 36 taxpayers finish their 1040 forms in an average of more than 12 hours? What's the probability of something with this distribution taking more than 12 hours? Probability of X being greater than 12. That's a right tail. Well, looking at the standard deviation, how many standard deviations is 12 above 10.53? Just guesstimate it without doing any calculations.
Just over 2.
No. 1 would take it to, 3 standard deviations is equal to 1. So 3 standard deviations would take me to 11.53. And it would take me another standard deviation would take me to 8.8. So it's 4 standard deviations, more than 4 standard deviations above the mean. The empirical rule, which I know you memorized because everybody in the class has memorized it, no doubt, tells us what? In between plus or minus 3 standard deviations is 99.73% of the distribution. So only 0.27% of the distribution is in the right tail above 3 standard deviations, and we're at 4.5. At least 4.5. How likely do you think this event's going to be? And I know I'm putting you on a spot.
Not likely.
I would say not likely at all. I think it's going to be like, point like 3, 4 zeros and then some numbers. But I'm just guessing. Why guess when we have this right here? No need to guess. What's this, 10.53? What is the standard deviation? 0.33. And we're looking at 12, right? The 4 decimal places is 0. It's really a remote probability of that happening. So what is it? It's point, how many zeros were there? 1, 2, 3, 4, 5. This is a very low probability event. Probability occurrence. That's what I would say. Is there another question? E. Would you be surprised if one taxpayer finished his or hers? Well, no, because look at, no matter what the distribution is here, the mean is 10.53. This is for individuals, not the average. And the standard deviation is 2. So 1 standard deviation above the mean takes me above 12 already. We're talking about the average of 36 people taking more than 12. That's a very rare event. But for E, no, that's only 1 standard deviation. Do you follow what I'm saying?
Yes.
You can say no. But remember, we're using this for E. So if I take 1 standard deviation, it's not even, it's 3/4 of a standard deviation above. So this should be, we don't know what the distribution is, but it's not as unlikely. I would probably put not as unlikely. Of course, I'd probably want a better explanation or deeper explanation from you. All right, let's see what 64 says. What problem we just do? 63? Probably 63 is like 64. Homework. 63. 64. World-class runners. It's, let's see. Let me just add stuff to 63 to make it look like 64. Probably that a runner will average between 142 and 146 minutes in these 49 marathons. Well, that's the sum of probabilities. Find the median of the average running times. Well, it's a normal distribution, so the median is the median, the mode, and the mean are all the same in a normal distribution. So that's a trick question. So first of all, you tell me, what's the probability, what's the distribution of this thing?
Well, for A?
64.
Standard normal distribution.
Wouldn't be standard normal, that would be a normal 0, 1.
Okay.
Mean of 0 and a standard deviation of 1. That would not be right. The only part about that was right was normal.
So it's just normal?
Not standard normal. Standard normal is a very specific normal distribution where the mean is 0 and a standard deviation is 1.
Okay, so it's just normal?
It would be normal, but what's the mean and standard deviation of it?
145 and 14.
No. That's of the individual.
Okay.
We're taking 49, the guy's running 49 marathons. They're known to run 26 miles in an average of 145 with a standard deviation of 14. Consider 49 races. Let X be the average of 49 races. X bar be the average of the 49 races. The mean is going to be this here. It's the same thing. It's the same thing. I'll spot you this one. We'll do this one for real. Let's actually do this problem. Might make you do more of it than me. Let's go back to problems, homework. What is it, 64? It's really poorly worded. Is it the average of the world-class runners in 49 different marathons? I guess that's what we're talking about. Because this is the average of averages, right? This is kind of a very misleading problem, the way it's written. Suppose the category of world-class runners are known to run a marathon in an average of 140. So all the marathons these people have run, world-class, however you define world-class, is 145 minutes with standard deviation of 14. Now they're taking 49 races, and let's say this is the average world-class runner runs it in 145 with standard deviation of 14. Now we're going to ask questions about the average of those 49 races. So the standard deviation is not going to be the same. It's a sampling distribution. Is that a little confusing? Of course it's a little confusing. Wouldn't be a stats class if it wasn't a little confusing. Let's put this up here. Let's make this big. All right, now we go back to what we did the other day. Did you study any of that we did the other day, yesterday? You can say no, because that's probably the answer.
Oh yeah, I did as much studying as I can.
That's
to try
okay.
to do the assignments on my own.
No one studies anyway. Why should you be different? Individuals, or in the population, let's put it population. Might be easier to say it that way. Population is normally distributed with what? What's it mean? Let me give it to you right there in the first sentence.
Wait. Suppose. 26. Or 40. I mean 145. Sorry, I was thinking the wrong number.
145. And a standard deviation of
14.
There we go. So the mean, let's just write it as 145. standard deviation. I don't know why I write it over again, but this way I can at least use it, is 14. Okay, that's population. Now our sample is what? Let's make that bold. Our sample says, okay, we're looking at a sample of how many? How many races?
49.
49 races. Isn't it nice? The square root of 49 is 7. How often does that happen in a real life problem? What's the mean of the sampling distribution now?
We said the square root, so that'll just be 7.
No.
Right?
If I ask you a question about the standard deviation, that would be a true answer.
Okay. It means the same, right?
Means the same. The average, you expect the average to be the same. But the standard deviations would be much smaller because we're taking an average of 49 of them. So it's not going to vary as much on the individuals. The standard deviation has a centering effect. It's a measure of dispersion, but you know, when I take the average, it centers. It's not going to vary as much as the individual race one will. I'm taking an average of 49 races. So the standard deviation here is going to be the same standard deviation as this, divided by SQRT of what? It's going to be 2. Why did it do that? Let's see, 1C. Okay, let's stop. Okay. This is going to be 2. 14 divided by the square root of 49. Square root of 49 is 7. 14 divided by 7 is 2. The answer shouldn't be surprised. You should be able to do some of the simple things like this in your head. Don't feel bad if you don't. You wouldn't be alone. The emphasis was on the word should. Find the 80th percentile for the average of the 49 marathons. Find the median of the average running times. Well, the median is equal in the normal distribution, the median, the mode, and that's an easy problem. All right, so we just did A. That's A, I guess. So we can say X bar, which is the X with the line over it, because I don't want to do the fancy formatting here, is normal with 145, comma 2. Okay, go here. I put 145, 2. Can I answer any question now?
Yeah.
I'm set to answer any question they ask. They want to know, find a probability that he's between 142 and 146, or that the average is 142 and 146. That's 62.47. It's 2, so 145 minus 2 should be, okay, plus or minus 1 standard deviation would be 143 to 147. Do I have the right numbers in here? Yes. All right, let me just check something. 143, 147, 68. Okay, yeah, so we have 142 and 146. Yes. So the in between is, my answer for B, which is a probability that 142 is less than X is less than 146. is equal to, what was that answer? Well, we're not done yet. Let's do the other part too. What's the 80th percentile? So I put 8 there. Now I got all the answers to my questions, right?
Yeah.
So I could copy this bad boy. Oops, and paste it in here. I don't need that big. I just need to show it, so if you turn it into me like this, I say, oh, they used my calculator, and they had the right numbers on the chart, and they picked the right numbers off the chart to put here. So what would you put there?
The number under the 80th percentile.
We're still doing B, probability of 142, X being between 142 and 146.
Okay, so then you just put the in-between column.
0.6247.
Yes.
That's good. 6247. And then C is what?
What's C asking?
Would be the 80th percentile.
B. CDF.
Now I give a percent of 80%. I want to know what the X value is. And here it is 146.68. I read that right. D, what's the median? And I would say trick question. Because the median, the mode, and the median, mode, and mean are all the same in the normal distribution. So it's 145. There you have it. I only saw one of the problems for you exactly.
All right, I see. Thank you.
You got it?
I got
Anything
it.
else?
I mean, I haven't really looked at chapter 8, so
We're not. Did I give homework in it? Yeah,
I believe you did.
I might have. Yeah. Let me stop recording.